Hey guys, in this tutorial for NodeCanvas, I'm going to go over every single composite node that NodeCanvas has. We're going to learn how they work, what the different options mean on them, and how they will impact the way your behavior tree flows, and how they can work together, as well as some examples for how you can make AI behaviors in a simple, intuitive way, but with complex and engaging results. So I have this basic scene set up where I have a bunch of waypoints. So these green spheres here represent a waypoint for patrolling. I have a white sphere, which represents the player. And I have this red cube, which represents the enemy. So I'm using a nav mesh here. So I have created a nav mesh for this ground. Inside the environment folder, I have the plane, which has the nav mesh on it. And I have these cubes, which I've baked the nav mesh from just to make some obstacles. And I have this object here, which is a door, which acts as an obstacle between this area of the playfield and this area of the playfield. And on my enemy, I have created a behavior tree. So I've just added a behavior tree owner, created a new bound behavior tree, and I have that tree there. And my enemy has a nav mesh agent on it as well. I've ramped up some of these speeds just so it's snappier and we don't get so much rubber banding. And I'm basically going to use this example scene as a way to demonstrate how each of these composites work. So these are all the composites available in NodeCanvas in the behavior tree. So if I right click or I press the space key and I go to composites, these are all the composites that are available to us here with all the descriptions. So let's go over each composite and break down how to use them. In order to explain how they're used, I'm going to use some examples. And so let's set up those examples first. So what I'm going to do is I'm going to add some actions and some conditions. So first, press spacebar or right click, choose action, and I'm going to copy paste this, Control C, Control V. And actually we just want 3 of them. And in this one, I'm going to add movement, pathfinding, patrol. The next one, I'm going to do movement, pathfinding, wander. And the last one, I'm going to do movement, pathfinding, seek game object. And I'm going to add a condition as well. So I'm going to create a condition just like this. And this one is going to be is active. Now, at this point, I just want to point out that I have the summary info enabled. If you disable the summary info, it's much more succinct and clean. But if you enable the summary info, you can see a lot more details, and this can be useful as you're working. All right, so the idea here is that I want to be able to set up these pathfinding actions and have this condition as well. So for the condition, I want it to be looking at whether the door is on or off. And so what I'm going to do is I'm actually going to add some variables. I'm going to add them to the graph. So I'm going to add a variable, and this is going to be game object, and this is going to be called door. Then I'm going to add one for the patrol points. And actually what I can do here is I can click this and click this little circle here. Then I can go down to graph, press create new, and that's going to create a target list for me here. And we're just going to leave it like this for now. All right. And then wander, we don't need anything here. He's just going to wander randomly within the nav mesh. And then for seek, we need a target. And so we are going to add, again, a new variable. And this is going to be also in the graph. And it's going to be called player. So we're going to call this one player, this one door, this one patrol points. And actually what I'm also going to do is I'm going to add a variable directly here called speed, and that's going to be the speed that he moves at. And we can hook that up into our 3 pathfinding actions. So here, graph speed, again here, graph speed, and the last one here, graph speed. So now when I change that speed variable, it will update it across all of these nodes very nicely. So now we actually have to assign these. And I could drag them directly into the graph like this. But what I can also do is I can use this little cog icon here, and I can change it to be exposed public. So I'm going to change all of these to be exposed public. And what you'll see here is that this is now gray to indicate that it's going to be overridden from outside. So whatever I put here, if it's overridden from outside, this value will not be used, but the value that is over here will be used. Now, none of these are currently overriding, as you can see, because it's gray. And all I need to do is press these little arrows here, which say override variable. So I'm going to override variable for all 4 of these. Then I can close my Blackboard variables. I don't need to worry about this. I'm going to set everything up in here. And this is really great for when you don't have your canvas open and you want to make adjustments, because I can change all my variables right in here and I get a lot of visibility. All right, so now let's assign them up. So we're going to put the player into the player swatch. I have a door here, so I'll put that door in there. And actually, I'll just turn that on for now. So that's right there, you see. Then speed 8 is fine. And then for patrol points, what I'll do, so I've created these patrol points. What I'll do is I can actually just lock the inspector, press create, drag and drop all of these, and there you go. And then I'll unlock the inspector. Perfect. All right, so now let's go back to our behavior tree. So I just double click to maximize, double click to minimize. So let's have a look at the first composite node, the sequencer. So it executes its children in order and returns success if all children return success. As soon as a child returns failure, the sequencer will stop and return failure as well. So to hook these up to our actions and conditions, we'll just drag it and drop it in, just like that. Now, the sequencer will happen from left to right, so it will check if self is active. If self is inactive, then as the description indicated, it will return fail, and this sequencer will stop executing. So if our door is off, none of this will happen. And let's have a look at that. All right, and I just realized, as you can see here by the summary information, if self is active, which is not what we want it to be asking if the door is active. And this is another benefit of having that show summary info enabled. If I had it disabled, it just says is active, and I don't actually know if I set up the door or not. So I'm going to turn the summary info back on. If self is active, that's not what I want. Instead, I'm going to tick this here, which is going to override. Then press that little circle, which is going to bind it to a variable. We've already created our variable. Go to graph and choose door. There we go. And now you can see if the door is active. So that's correct. So if the door is active, it's going to random patrol points. When that finishes, it's going to wander. And then when that's finished, it's going to seek the player. All right, so let's see it in action. We press play. Our door is inactive. So he's not doing anything. He's evaluating this. Then I turn the door on. And you see now he's randomly patrolling a patrol point. Then he's wandering. And actually the wander here is set to repeat, so we don't want it to repeat. I'm just going to turn the repeat off. Otherwise it's going to do that forever and never move to the next node. So let's try that again. So door is inactive, he's not doing anything. I turn the door on. Now he goes to a random patrol point. Then he wanders. Now he's seeking the player. He gets as close as he can to the player. And then he moves back. And he's cycling through this sequence here. And you can see the current sequence by the yellow node. And if I turn the door off, you see he will continue this sequence here. He will continue all the way here. And when he finishes and gets back to the top, now he will stop executing. And if I change the order of these, so if I change the seek player to be at this front, and all I need to do is drag it. If I drag it like this, NodeCanvas is smart enough to figure out that this should execute first. It's always going to go top to bottom, left to right. So if I play now, and the door is inactive, he's actually going to still seek the player first. See, there he goes. He seeks the player. Then, because the door is inactive, that's where he stops the sequence. Until the door becomes active, then he does the random patrol, seeks the player, and goes through everything again. And he stops because the door is now in an inactive state. All right, and so that's the default behavior of our sequencer. But if I click the sequencer node, you can see here that I actually have two options here. I have dynamic and I have random. So dynamic, if true, then higher priority children are reevaluated per tick, and if either returns failure, then the sequencer will immediately stop and return failure as well. Now, just to clarify before we go on, this is currently set, so this behavior tree is currently set to repeat. So if this fails, then it's going to re-enter immediately. And I'll show you that just for clarity. Just this, I think, will make it a bit easier to understand. So I've turned repeat off, and you see he seeks the player, and door was inactive, and he has stopped, and the whole graph is finished. However, if I have repeat turned on, then what he's doing is he's doing this, he fails, but he is constantly evaluating this. And then when it becomes true, then he moves on. And so in the case of the dynamic, if I turn this on, and let's say my door is true to begin with, and I'm going to make this not repeat just to demonstrate. So he goes through there, and I turn the door off, you see it exits, it fails straight away. If this was not dynamic, it doesn't matter. I've changed the door, and it didn't matter until he reached the end and he finished his entire sequence. So let's put it back on repeat, change it to dynamic, and the idea now is that he's going to go through, he's going to seek the player, he's going to check if the door is active. If it is inactive, he's going to do a random patrol point. But while he's doing this or wandering, if I change the state of this, it's going to exit and it's going to go back to the beginning and go through the sequence from left to right again. And actually what I want to do is I want to invert this condition. So I'm going to click that, and let's just rearrange this again. So we have, if the door is not active, we're going to seek the player. And after we seek the player, we're going to do random patrol and then wander. And we've got it on dynamic so that if the door becomes active at any point in these actions, then it's going to stop. It's going to go to the beginning and it's going to get stuck here. So there we go. Our door, because our door is active, it's not going to do anything. Now I do this, he seeks the player, I press it on, immediately he stops because we have it on dynamic. And I do this and he will go straight back. And note that he doesn't go back to the node he was on, he goes back to the beginning. And so when I turn the door off, he's going to seek player, not continue the random patrol points. Just like that. All right, and now the second option, let's turn off dynamic for now. The second option is random. So if this is turned on, then the children order of execution is shuffled each time the sequencer resets. So when it enters, it will shuffle. So maybe it will do 1, 2, 3, 4. Then at the end of this, it's going to reshuffle and maybe do 1, 2, 3, 4. Then at the end of this, reshuffle again, and so on. So for this example, I'm just going to disconnect the door as active for now. And it's going to choose either seek the player, random patrol point, or wander. Well, it's going to do all of them, but it's going to do them in a random order. So let's see that. So he's wandering, just turn that door off. He's seeking the player. So that was the second action. Now he's doing the random patrol points, seek player, random patrol points, wander, and there we go. And actually the wander is kind of very short. So what we can actually do here is we can just add a repeat. So I'm just going to add a repeat decorator on the wander, make him do it maybe 5 times. There we go. So there you see he's wandering around. He's finished wandering around. Random patrol, seek the player. Well, he got as close as he could. And there we go. And that's basically how the sequencer works. So I'm going to set this back to not be random. And what I'm actually going to do now is I'm going to add a sequencer within the sequencer. So I'm going to copy and paste. And what I'm going to do is I'm going to add a new action. So action, and I'm going to make a log, debug log. And we're going to call this, I'm going to say it's seeking. And now I'm going to take the seek player, move it down here, and connect these up just like that. Remember to delete that one there so we can connect it. And then simply drag from the start sequencer and drag it into our little sub-sequencer here. All right, so now when we play, he's going to go in order. So he's going to say log seeking, seek the player, move out like that. All right, now, what if this fails? So let's put the door is active as a condition here. And actually, what I can do is I can put the log seeking, and let's say change it to I will seek. Then I'll copy that, paste it here. Door was open. Great. Let's move that over here like that. And so what you see is going to happen is he's going to come into here. He's going to log I will seek. If the door is turned off, he will fail at this point. And he will go back to the beginning, and he will just continuously log I will seek until the door is active, at which point he will log door is opened, great, seek the player. Then, because this succeeded, he's going to go and do the random patrol, and then he's going to wander around. So let's have a look at that. So our door is currently on. So he's saying, I will seek, but he's failing here, and it's not going to continue the sequence. I turn the door off. Cool, the door was open. He seeks the player, and he goes to the random patrol points. And because it's not dynamic, I can turn that door on and off with no problem. It's not going to interrupt the sequence. All right, good. So now let's look at the next composite. So I'll move this over here, and let's have a look at the random selector. So unlike a sequence, the selector is going to execute its children in order and return failure only if all children return failure. And as soon as a child returns success, the selector will stop and return success as well. So the selector is trying to find the first child that can succeed. So we're going to use the same nodes. So I'm going to grab the seek player, copy paste these nodes over, random patrol and the wander, 5 times wander like this. And I'm going to right click random, set as a start. So we don't want it to start here. We're going to put that to the side. Okay, so let's connect this up. And currently it is set to be random. For now, I'm going to set it to not be random. So it's going to select the first thing that succeeds. Well, let's turn that door off. Let's play and see what happens. All right, he seeks the player. He succeeded and he has stopped. He does not go to the random patrol because this is a selector, not a sequence. In the sequence, he would go to the next one, but in the selector, as soon as something succeeds, that's where it ends. And of course, if I change the order of this, so I will make him do the random patrol instead of the seek player, he's going to do the random patrol instead, and he's going to continue to random patrol because he can. So in the sequencer, he would random patrol 1 point, and then he would move on to the next. In this case, he random patrols 1 point, succeeds, and it goes back, and he will do a random patrol of the next point. And he will never enter seek player because this always succeeds. So what we can do then is we can bring our condition in. So I want to take that door is inactive, put it in here. And now you see here, I can't just connect it up like this. If I connect it up like this, so it's going to fail it, and he's going to do his random patrol points like that. And if I turn it off after he finishes that, you see, because the door is inactive, this has returned true and it has stopped the execution. This is not really what we want to do. We want to make him only seek the player if the door is inactive. So we need to tie these two together somehow. So how do we do that? Well, just like we did over here, we can use our sequencer. So I'll copy that, put that there like that, connect it in. So now by using these in combination, we're able to achieve this conditional behavior. So he's going to start, he's going to try to do this. If the door is turned on, it's going to fail. And because it fails, this cannot be selected. He's going to select this one. So let's have a look at that. So the door is inactive, so he successfully does this, and he stops execution. Let's turn the door on. Okay, so he's going to do random patrol points, and he's going to continue doing that. We're going to turn the door off. He finishes his random patrol point, and now he can seek the player. I turn the door on, and now he's going to do the patrol points again. All right, and just like our sequencer, we have access to the dynamic and random settings here. So for random, he's going to choose a random one of these. So he randomly chose to wander around, and when he finishes that, he's going to go back, choose another random one. So he's wandering around, he's finished. He actually chose this one, but it failed. And because this failed, he went on to evaluate the next one, which happened to be the wander again. And because that succeeded, because he was able to process that, he continued that. And here he chose random patrol. And if I turn the door off, next time it randomly chooses this, he can actually do it, so he'll enter and process that. Okay, so let's turn random off and let's turn dynamic on. So remember, with dynamic, he's going to reevaluate all the children, all the higher priority children, so these ones here. And what you'll see here is that he is continuously evaluating this, and this is continuously coming back as false. And if I turn my door off, it actually has now returned as true, and it works, just like that. Now, what you'll notice is that if I toggle the door, while he's doing that, it has no effect. And that's because although this is dynamic, this is not dynamic. Therefore, once he goes into here, and this is evaluated as true, he does the seek player action, and he'll keep processing that despite this changing, just like what we had over here. And so we can also make this dynamic. So what you can see is he's waiting for the door to be off. I turn the door off, he does this, but I turn the door on, and he moves straight back to the random patrol because we have used dynamic here to reevaluate if the door is active and return failure if it becomes inactive. All right, so that's great. Let's move these over there. And just to summarize, the sequencer goes in order until it finds something that fails, whereas the selector chooses the first task that succeeds. All right, so let's have a look at the parallel node. So I'll just set that to start. Now the parallel is going to execute all the children simultaneously and then return success or failure depending on the selected policy. So you see here, the policy here is first failure, but we can also choose first success or failure. So the example that we've been using so far is not really going to work for this because we have 3 pathfinding nodes: the seek player, the random patrol, and the wander. However, our first failure is going to be executing all of these at the same time, and they kind of conflict with each other. They're all manipulating our navmesh agent. So we're going to use a different example for the first failure. So I'm going to get rid of the random patrol and get rid of the wander, and we're going to just use seek player. And here, we're going to stay on the first failure policy, and we're going to add some conditions. So let's copy our condition for the door being inactive, and let's connect that. And let's make another condition, and this one is going to be player active. So if the door is inactive and the player is active and the seek player does not fail, then this is going to basically continue running. So let's have a look at that. So right now our door is on, so our door is active. Therefore, because the door is active, it's going to fail this. And even though here the player is active, passed, it's not actually going to run the seek player because this failed. And since the player is active can resolve in the first frame, in the first cycle, then this is just marked as completed. Now, if I turn the door off, now he can do the seek player. And I've just added a little script so I can move my player around. All right. Now remember, he's going to finish doing the seek player before he evaluates again. And so here, even though I've turned the door on, he's still going to move towards me. And let's actually just change this so that his keep distance is a bit more generous. There we go. So we'll turn the door off. And even though I toggle it, he's not going to reevaluate until he has finished that seek. Now, unlike the selector and the sequencer, it does not have a dynamic option, but it does have a repeat option. So if repeat is true, the finished children are repeated until the policy set is met, or until all children have had a chance to finish at least once. So this is very similar to how the dynamic works. So if I turn that on, and let's just set this to the first failure. So we're using it to check if these conditions are okay, and if they are, we're going to seek the player. And remember before, when we didn't have it on repeat, it would not interrupt the seek if one of these changed. Okay, so here we go, he's seeking, and now this time, if I turn the door on, he stops immediately, because the repeat is telling it to reevaluate. Now this is not really a great example because these don't really happen in parallel. So let's put a parallel action in here. So we're going to seek player, and at the same time, we're going to log a value. So we're going to add an action, assign an action task, log, so debug log, seeking, or I'm coming for you maybe. I'm coming for you. There we go. Now you see here, he's going to say I'm coming for you for 1 second, and he's going to seek the player. Now, neither of these are going to fail. Neither of these can fail. So what we're going to do is we're going to stop it on the first success. So it's going to run these two in parallel, and the first one that succeeds is going to stop the execution. So let's have a look at that. So he logged for 1 second, and actually, because it's on repeat, he's going to keep doing that. So for this example, let's just turn the repeat off here. So you're going to log, I'm coming for you to 1 sec, and you see he stopped because this returned as true, and he did not go to seek the player. If I set that log to be 10 seconds instead, then the seek player is going to be the one that actually returns true. So the parallel composite is really good for when you need your characters to do two things at once. Maybe there's a node that is checking whether they should change their target, and the other one is chasing their current target. So you can have the one that is checking if they should change their current target. If that returns success, then that's going to cancel out of this, and then move on to whatever else your tree is potentially doing.